All right, quick little notes on bonding and classification of matter. What happens when atoms stick together? What are the primary classifications of matter? The primary classifications of matter involve elements, which are substance made from only one type of atom. So you can see the red atoms are an atom of a single element, but you can also have molecules of an element, like is shown in the purple molecules of an element. And when you have a molecule with two of itself bonded together, or two elements bonded together like that, we call that a diatomic element. Di meaning two, atomic meaning atoms. And the common diatomic gases are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And so when they occur in nature, they're always in pairs. Compounds are substances made from two or more elements bonded together. So you can see in the image there's some type of purple element, and then there are three green elements bonded to it. Pure substances are substances where all particles present are identical. So you could have a pure element with one or two atoms, or you could have a pure compound and it would be all molecules of the same compound. Mixtures involve more than one type of substance, whether that's an element or a compound, and these are not bonded together. So a mixture of elements and compounds has the elements that may or may not be bonded in a diatomic molecule, and then you also have maybe another element or a compound floating around, but they are not bonded together. We can predict for our compounds what kind of bonding they might do based on looking at the periodic table. And the stair-step line differentiates our metals from our nonmetals. Our metals are on the left-hand side, and our nonmetals are on the right-hand side, shown in green. So if you have two metals, that's a metallic bond. If you have one metal and one nonmetal, that makes an ionic bond. And if you have two nonmetals, that makes a covalent bond. Hydrogen is a notable exception to this because it just does whatever it wants. Even though it's on the metal side of the periodic table because it only has one valence electron, hydrogen usually acts like a nonmetal when it bonds. So water is a great example of that. Hydrogen bonded to an oxygen makes a covalent bond, and that bond is also polar. We'll talk in detail about what that means. And then oxygen and hydrogen are sharing electrons, and the oxygen can hold the electrons tighter than H because oxygen has a higher electronegativity, and that's what causes this element to be, or this molecule, sorry, to be polar. The three types of bonds are as follows. The first type is a metallic bond, and it's a fluid matrix of electrons holding together the metal atoms. So that can be kind of hard to visualize, but in the image below, it shows how the metal atoms, which are shown in blue with a big plus sign, might have one or more electrons that are available in their valence to move around, and they just start all sharing all their electrons at the same time. It's like a big happy electron sharing commune. And this is why so many metals transfer electricity so well, because electricity is just electrons, and so it can just move through the metal from one location to another. It's pretty slick. Sometimes you will hear this called like a sea of electrons. This image calls it a swarm of delocalized electrons. Delocalized means they're not associated with any particular atom. But I like a sea of electrons because swarms make me think of insects and it's scary. Next type is an ionic bond. This is between two oppositely charged ions. So if you have a sodium atom and it has one valence electron, and you have a chlorine atom which has 7 valence electrons, chlorine is much more electronegative than sodium because it has a stronger magnet and they're in the same row. And because it has that one empty valence spot, it really wants that electron. So instead of just sharing the electron to complete chlorine's octet, chlorine actually takes that electron away. And so then sodium has a 1 plus charge and chlorine has a 1 minus charge. And they're attracted to each other like little magnets. So they're not directly hooked together by sharing electrons, but they are held together by attraction between their two opposite charges. What's important to remember here is that electrons get totally transferred from one atom to the other. Lastly, we have covalent bonding, which is where two atoms share valence electrons. So co is referring to sharing and valent is referring to valence electrons. For example, here you can see that the goal is to achieve a set of 8 valence electrons. So fluorine has 7 and this fluorine has 7. So if they decide to share, they can each pretend that they have 8. So now the fluorine on the left thinks it has 8 electrons and that its octet is complete. And the fluorine on the right thinks the same thing because they're sharing those 2 electrons. And because they're sharing those 2 electrons, they're really hooked together and bonded together strongly because of that. Oxygen and hydrogen do the same thing. We were talking about them a little bit earlier. And so each hydrogen has 1 electron. Hydrogen really only wants 2 valence electrons, so it can look like helium because he's so tiny. He couldn't hold on to any more electrons than that. But oxygen does want 8 electrons. So if it gets it from 1 hydrogen, then it thinks it has 7 and it's happy. And then if it attracts another hydrogen, then it thinks it has 8. And each hydrogen thinks it has 2. So hydrogen thinks it has a stable duet like helium, and oxygen thinks it has a stable octet like neon. And there was much rejoicing. The last piece we want to look at is introducing this idea of covalent polarity. So there's 2 types of covalent bonds. Nonpolar covalent, that's shown in red on the far left. You can see that our atoms are sharing a pair of electrons and they're sharing very equally. They both have the same size electron cloud. The second situation would be polar covalent. You can see here A is sharing electrons with B, but B is more electronegative, so it can pull more of the electron cloud onto its side, and so it ends up being kind of lopsided. Then the last scenario would be that B is so much stronger than A that it just takes the electron and gets a negative charge, and A gets a positive charge. That's what happens with sodium and chlorine, right? Sodium has 1 electron, chlorine has 7, and so they could share, right? And then sodium would think it had 8, and then chlorine would think it had 8, but chlorine is so much more electronegative, it just takes that electron all the way away. And then sodium's like, well, I guess this is fine because now I have a full octet anyway, and I look like neon. so it works out in the end. Polarity is just the separation of charges due to unequal sharing of electrons. And if we think about poles, right, we have the North Pole and the South Pole. They're separated. We know that there's some type of magnetic field, right, because our compasses point north. And so that's all of these words, right, are coming from the same roots. And so this is a separation of charges, and it's because of that unequal sharing of electrons. So ionic bonds in some ways are like polar covalent bonds gone haywire, right? They're super intense to the point of actually stealing the electron. Polarity is caused by differences in electronegativity between the elements in the bond, as I mentioned. So when molecules are polar, we say that they have a dipole, di meaning two poles, right, two charges. One side is slightly positive and one side is slightly negative. So these little magnets are not as strong as an ionic bond, but they are strong. And that is all she wrote. Okay, so hopefully this puts you in a good place after the classification of matter POGIL, and we're ready to rock and roll on the bonding POGIL. Thanks, you guys.